Hello everyone. In today's digital world, Node.js has emerged as a powerful tool for building fast and scalable network applications. From web servers to real-time chat applications, Node.js has transformed the landscape of server-side development. In this video, we will dive into what exactly Node.js is, its building blocks, and talk about how its architecture enables developers to build high-performance applications. We'll talk about Node's event loop and its single-threaded model, Node's callback functions, which enable asynchronous operations, and then finish off talking about where not to use Node. So let's get started. Let's start talking about what Node is. Node.js is a JavaScript runtime built on Chrome's V8 JavaScript engine. What makes Node.js unique is its ability to execute JavaScript code on the server side, allowing developers to use the same language for both client-side and server-side development. This unification streamlines the development process and fosters code reusability across different layers of the application. Now, let's take a closer look at the architecture of Node.js. At its core, Node.js consists of several key components. The first is the V8 engine. Node.js leverages Google's V8 JavaScript engine to execute JavaScript code, the same engine used behind the Chrome browser. Ryan Dehel, who created Node, took the V8 engine and wrapped it with some other functions and created Node.js, which allows us to write JavaScript in our server-side code, and the V8 engine compiles JavaScript code into machine code, making it highly efficient and performant. Node.js relies on libuv, an asynchronous open-source I/O library for handling asynchronous operations. libuv provides an event loop that allows Node.js to perform non-blocking I/O operations, making it ideal for handling large number of concurrent requests. Node.js bindings act as a bridge between JavaScript and the C++ libraries, enabling developers to access low-level system resources like the operating system and file system that are not natively supported by JavaScript. Node.js comes with a set of core modules that provide essential functionality for building applications. These modules include HTTP for creating web servers, FS for file system operations, and events for handling events. Talking about events, one of the key features of Node.js is its event-driven architecture. If you're familiar with other server-side technologies, Node handles web requests differently than others. One approach many of these server-side technologies use is multi-process approach, where there is a pool of processes and each request is handled by a process. Code running in one process is isolated and is not aware of the code in another process, and the number of requests we can serve simultaneously is limited to the number of processes in our pool. Another way is multi-threaded approach, where a process can have multiple threads and each incoming request is handled by a thread. In this case, since the threads are a part of a single process, even though code is isolated to the thread, they are aware of the other concurrent threads, especially when accessing shared memory space. Again, the number of concurrent requests is limited to the number of threads in the process. Node works on a single-threaded event loop model. There is a single thread in a single process which handles all incoming requests. So I/O operations like request to access a file, an incoming HTTP request, etc. trigger events. The event loop receives the event and hands it off to the underlying I/O operation. In Node.js, most of the I/O operations are non-blocking and asynchronous, meaning that the application does not wait for I/O operations to complete before moving on to the next task. An analogy you would often hear to understand is of a restaurant. In a restaurant, a waiter receives the order from a customer and gives it back to the cook, and while the cook is preparing the order, goes to the next customer for his or her order and gives it to the cook. And when the order is complete, the cook notifies the waiter, who then delivers the order to customer A and customer B. This is asynchronous. If the waiter had waited for the cook to finish the order before going to the next customer, that would be synchronous operation, and as you can imagine, would slow down the operations and we'll have a lot of unhappy customers. There are callback functions which you write which are notified when the event has been processed or complete. So these are special types of functions which are passed as arguments to the main function. When the main function execution completes, the callback function is called. For example, when the file read activity is complete. This approach allows Node.js to make asynchronous calls and handle multiple requests simultaneously without blocking the execution thread, resulting in a better performance and scalability. Using this model, there is no shared memory as it is a single thread, and Node will service one callback function at a time. So if there are multiple incoming HTTP requests, it can only handle the callback function one at a time. So it's our responsibility as developers to spend as little time in the callback function so that Node doesn't have to spend too much time in there and we can service more requests more efficiently. So this brings up the point as to where Node.js should not be used. It should not be used for CPU intensive operations as its async model depends on its thread being released pretty quickly after getting the instruction to go on to the next instruction. But if your instruction requires it to do a lot of work which would take time, then it would not be suitable. To recap, Node.js is a powerful platform for building fast and scalable network applications. Its architecture, built on the V8 engine, libuv, and event-driven model, enables developers to create high-performance applications with ease. We talked about Node's event-driven model and callback functions, which allow for asynchronous operations, lending Node its high-performant nature. Finally, we mentioned that Node would not be a suitable option for CPU-intensive operations. Thanks for watching.